everyone, welcome to Tech on Cloud. I hope you all are enjoying Docker Fundamentals series, and today we are here for Docker Fundamentals day 6, and today I would be talking about volume mapping, then how we create a Docker image, and then I would be also talking about DockerFile and the layer architecture of the DockerFile. Okay, so stay tuned, enjoy yourself, and learn Docker with Tech on Cloud. So let's move to the first slide, which talks about volume mapping. So volume mapping is similar to the port mapping, but there the ports were used and here volumes are being mapped. So let me tell you in brief what is a volume. A volume is a persistent storage. Okay, so the volume is stored in Docker container, okay, which stores the data. For example, if you want to run a MySQL container and there would be database and tables coming to an action, and that will be stored in location /var/ library /mysql path inside the Docker container. So the Docker container has its own isolated file system, and any changes to any files happen within the container are stored there. Okay, so let's assume your application experience a heavy flow of data and somehow it get crash and your pod is down. Okay, so the container along with all the data inside it goes down and your all data is gone. Now if you would like to persist data, you would want to map the directory outside the container, which is in purple color in this slide, and this path is theta, and it would be mapped to the container directory, that is var library and MySQL through -v flag. Okay, so this way, when Docker container runs, it will implicitly mount the external directory to the folder inside the Docker container. Okay, and this way your all data would be stored in the external volume at /data, and this will remain even if you delete or your container gets crashed. Okay, so in simple terms, it is just an backup data storage which we are taking along with our container storage, and we are mapping it so that we have a backup of our data. Okay, and the command used to do so is docker run -v /data, which is the path of the external database, or we can say that external container, and the variable, and which is mapped through colon to var lib mysql. Okay, let me make the path a little bit correct. Yeah, so that is what volume mapping is all about. Let's move to the next slide and see how to create a Docker image. Okay, so the Docker image is been created using DockerFile. As you can see on the screen, the steps involves: first we need to create a DockerFile, second we have to build a Docker image, then we have to tag it. The tag it is optional, okay, and that build is happen with the help of docker build your Dockerfile path -t the tag name. It will be tagging it along with building the image. Okay, then we would be pushing the image with the image name into the registry. Okay, so let me show you an example of a Docker image. We have also seen how the image is being created in our Docker Fundamentals day 5. Okay, I did a little bit example there, and it has that Docker file coming into the action. Okay, So let's move to the terminal. Here we are on our terminal, and let's go inside the path and see the Docker file. Okay, so let me quickly type out the path cd, and it would be GitHub workspace and list out things cd docker file. No, it's I have to open it, right? Yeah, you can see on the screen this is the simple Docker file, and this is in detail I would be talking in the next slide that what this line means. But yeah, this is the first step, and second step involves the step to build a Docker image. So sudo docker, then I would be doing build, and that build would be having the path, okay, of the Docker file. So let me do a pwd there, then sudo docker build /home check on cloud GitHub workspace practice, then port mapping. Okay, let me run it. You can see this image is starting to build, and it is built. You can see exporting the image, exporting the layers, and writing the image. If you do sudo docker images, see, this is the only late image which is being built. So it is pre-built and it is present locally, so it is not fetching anything, and so because there is already present locally. So this is the first step, the Docker file, and we are building it. Then I would be pushing it to the registry. So the registry would be the Docker Hub. I have not configured it with my terminal, so I would not be able to implement docker push command here, but you can implement that by setting it up. It just take few minutes. Okay, so let's move back to the slides. So now you saw how to create a Docker image. Now let's move to the path where we will see what is DockerFile. So DockerFile is basically a text written file with a specific format in which the Docker can be used. Okay, then it consists of instructions and arguments, and these instructions consist of a series of commands like from, run, copy, export, cmd, entry point, and like commands, and which we use to write a Docker file. And these commands are written basically in the left hand side, and the arguments are in right hand side. Okay, so let's take a closer look at that Docker file which we just now saw in the previous terminal. Okay, so let me go back to that terminal here. So let me explain you little things. If you go and see the highlighted portion which I have done, it is basically no extension with the file. It's just a Docker file. You can see when I implemented cat command. So Docker file is just a text written file in a specific format that Docker can understand. Okay, so in this Docker file, everything on left is in capital letter. That is an instruction. Okay, and in this case it is from work directory, then copy, run, expose, cmd, and each of this instruction Docker to perform a specific action while creating an image. Okay, then everything on the right hand side is an argument to those instructions. Okay, the first line says from Golang latest, which means it has to define that what the base OS should be for this container. Okay, every Docker image must be based on another image. Okay, either an OS or another image that was created before based on an OS. You can find official release of all operating system in Docker Hub. Note, all the Docker files should start from command. Okay, or you can say from instruction. The run instruction instruct to build the Go app. Okay, and the work directory is setting up the work directory for this container in Go source app path. Okay, then we are copying that source code into the Go src app path using the copy command. Okay, now expose command exposes the application at a particular port. Then cmd refers to the command which we run. Either for there is two type to execute your application. One is cmd and one is entry point. So the example of cmd you are seeing on a screen, and entry point allow us to specify a command inside it that will run when the image is run as a container. Okay, now let's talk about the layer architecture. So when we build the images, if you will see that it is built in different layers, and at the end it will say exporting to image layers. Okay, so each line of instruction creates a new layer in the Docker image with just in changes from the previous layer. So this layer to this layer there will be certain changes, that's why it is building it. Okay, the first layer is a base of an Golang application, if you have seen in the Docker file. The second instruction that creates the second layer is which installs the work directory. Okay, so it's not installs, it setups the work directory, then it copies it in the Go src app, then 4 of 4 it runs build main and then exports the image and layers and writing a image in SHA-256 format. Okay, since each layer only stored the changes from the previous layer, it is reflected in the size as well. If you look at the base Golang image, it would be around, okay, it is not said here, but you can see the size of the image is around 852 MB, and this is how a Docker layer architecture is being done. Okay, okay. Now the build output. So the build output says the things which I just referred for an architecture, layer architecture. So this build is also means a Docker build output is also an example of a layer architecture of Docker, which it follows for each command in the Docker file. So when you run docker build command, you could see the various steps involved and the result of each task. You can see there is layered as 1 out of 1. A total 9 tasks were allotted to it, and this is all done. So all the layers built are cached, so the layers architecture help us to restart docker build from the particular step in case it fails, or if you were to add new steps in the build process. So means if it fails and if you restart it, it will be joining it, means it will start to run at the place where you have left it over. Now that's all for docker file and its architecture and its layer architecture and the output which it throws. Okay, so now a question comes, what all things you can containerize. So you can containerize almost all the applications, even simple ones like browsers or utilities like curl commands and many things, basically all. And going forward, you can see in coming world, means in coming time, this containers would be more ethnic, we can say that more demanded things and in market. Okay, what I can say, and because it makes the installment of the things very easy. You have to just run a simple command and your application is is directly on your local machine. Okay, so that is all for today. I hope you liked this lecture. I talked about volume mapping in the start and how to create a Docker image and the Docker file, its layered architecture, and we see what the Docker output says. And that's all for today, guys. Tomorrow we will be seeing something for Docker Compose, then a little bit about Docker Swarm. Then we will be seeing in good explanation about Docker networking. So it is so far good going for me as I have planned it. So stay tuned and learn with me the Docker. If you have any questions, please comment it out in the comment box, and if you like this content, please subscribe my channel, like this video, share with your colleagues, and that's all what I could say. And till then, bye bye.